Welcome, Integrated Math 2 students. Today's lesson is a two-dayer. We are going to be factoring quadratic trinomials. This is going to be a big idea. This is a big skill that you need to have down as you walk in the door for Integrated Math 3. So this is going to be very important. So we're going to spend 2 days on this process, kind of level 1 today, next level tomorrow. All right, before we do that, though, I want to give you another method for multiplying binomials. It's going to be called the FOIL method. So let's take a look at that. FOIL stands for first terms, outer terms, inner terms, last terms. So in our example, x minus 8 multiplied by x minus 2, our first terms are the x times x, which gets us x squared. Next, our outer terms, the outside terms, are the x and the negative 2. Multiply those, we get negative 2x. Next, we have the inner terms, or inside terms. So that's the negative 8 and the x. You multiply those, you get negative 8x. Finally, we have our last terms, which are the negative 8 and the negative 2. So you multiply negative 8 times negative 2, you get positive 16. So now we just add all the terms up and combine like terms, which are the negative 2x and negative 8x, and we get our answer, x squared minus 10x plus 16. Here's the same problem with the generic rectangle. I just want you to see it. It's what we were doing before the generic rectangle, which I still want you to be able to do, but you can see where the first term shows up here with the x squared and the f. Then the outside term, the outer terms, is the negative 2x. The inner terms is the negative 8x, and the last terms are the 16. So generic rectangle is just another way of organizing the multiplication process. Another way you can think of this is like double distributor property. If you look at my original up there, expand x minus 8 times x minus 2, look at my rainbows. It's like we distributed the first x first, and then we distributed negative 8. So FOIL method is really just double distributor property is what we're doing there. All right, I want you to try this one. See if you can do it in your head. If you can't do it in your head yet, that's fine. Pull out a piece of paper and write it down. But I want you to do the FOIL method here and give me your answer. So the first terms, I multiply those, I get x squared. Then my outside terms, I get 4x. My inner terms, I get 9x. Okay, 9x plus 4x is 13x. Then my last terms, 9 times 4 is 36. So my answer here should be x squared plus 13x plus 36. All right, if you need to write out the 4x and the 9x, by all means you can do that. But I'd like to get to the point where you can do this in your head. All right, try this one. 2x minus 5 multiplied by 3x plus 7. Use the FOIL method. What do you get? First terms, 2x times 3x, that's 6x squared. All right, outer terms, 2x times 7, that's 14x. Inner is negative 5 times 3x is negative 15x. All right, 14x plus negative 15x is negative 1x. And then the last term is going to be negative 5 times 7 is negative 35. So in this one, we get 6x squared minus 1x minus 35. Okay. One more. 5x minus 3 multiplied by 8x minus 1. Use the FOIL method. What do you get? Okay, multiply the first terms, 5x times 8x, that's 40x squared. Outer terms, negative 5x. Inner terms, negative 24x. Combine like terms, that's negative 29x. And then negative 3 times negative 1 is positive 3. So on this one, you should have got 40x squared minus 29x plus 3. Let me just show you the whole process again in case some of you are lost right now. 5x times the 8x is how I got the 40x squared. When I said the outer terms, outside terms, 5x times negative 1, that was negative 5x. inner terms, inside terms, the negative 3 and the 8x, that's negative 24x, right? And then negative 3 times negative 1 is the positive 3. So what I was doing in my head here is this part here, combining the like terms to get the negative 29x. I want you to take down the gold notes. And I'm going to give you two methods today. So method one is kind of the big idea where I'd ultimately like you to get to when you're going into IM3. Not necessarily for today. This method is going to be a little bit harder when you're just starting out. Our second method is going to be the way we're going to practice, and you're going to see how this first method works. And that's going to be how you show your work. Because the first method is really how you do in your head. But when I want you in IM2, I want you to be able to show me how you get there, how you get the answer. So we'll be using method 2 for our work process, at least for the first part of IM2 here till I get to the very end. Maybe then I'll let you just do it in your head. All right, so here we go. Our example is x squared minus 10x plus 16. That's our quadratic trinomial. It's in the form ax squared plus bx plus c. The first thing we always do when we look at our factor is there a greatest common factor? Is there a GCF? In this case, there's not a GCF, right? The 16 doesn't have an x, and then it's just 1x squared, so 1's not going to be a greatest common factor. We're not going to use 1. So this one doesn't have a GCF for us to pull out. So then step 2 is we know when we factor this, it's going to be a binomial times a binomial. That's going to be factored form. So I can write the parentheses. Then your next step would be, what are your possible factors for the first term? So x squared, 1x squared. Well, that's 1x times 1x is really our only option. Now, some of you might be thinking, well, wait a minute, Mr. Blank, what about 1x squared times 1? You're right. Those are definitely, that's possible factors, but it's not going to work in this binomial situation, right? Because then you'd have a 1 as your first term and one of the binomials, which would just combine with the other number, and you wouldn't have a binomial. So we know you're going to be pulling out the x from both factors, okay? Then your next list is going to be, what are your possible factors for the c value, the last term? So in this case, it's 16. So my possible factors are 1 and 16, 2 and 8, 4 and 4. Okay? So now what we have to do, this is the part you do in your head, is use FOIL to figure out the combination of factors that will give you a sum of the outer and inner terms to equal that negative 10x. So there's going to be different combinations. So since this is positive, since c value is positive, I know both signs have to be the same for my c value. So these are going to be both positive or both negative, right? So it could be negative 1, negative 16, negative 2, negative 8, negative 4, and negative 4, which is the way I'm going to go because I know when I add them up, I have to get a negative 10x. So here's in my head, I'm thinking, okay, it could be x minus 1 times x minus 16. It could be x minus 2 times x minus 8. It could be x minus 4 times x minus 4. Okay, which one is going to work? Well, if you do x minus 1 and x minus 16, when you get the b value in between, you're going to get negative 17x. When you do the negative 4 and negative 4, you're going to end up getting negative 8x here, so that's not going to work. But when you do x minus 2 times x minus 8, you're going to get negative 10x. This combination is going to work, so that would be your factors. You write out your factored form, and you would have used this one here. If I can get my pen to work. This is the right one, right? X minus 2 multiplied by x minus 8. Again, I just want you to see the big picture, how we could factor this in our head for now. But now I'm going to give you another method that we're going to use kind of help you with this process, because this is a challenging process for a number of students, especially if you're not real good with your math facts. It can take you a while. So here is method 2, which is going to be our bread and butter as we're learning this. So we're going to have what's called a diamond and a generic rectangle. The diamond is always going to be set up so the top is your A times c. It's the product of a times c. So in this example here, x squared minus 10x plus 16, we know a is 1 and c is 16. So AC is 16. So in the upper part of my diamond, I'm going to put 16. All right. Then the sum is going to be the b value. In this case, my b value is negative 10. So that is my negative 10. So now the way the diamond works is we need two numbers that when you multiply those numbers, you get 16. And when you add them, you get negative 10. So when we do that, you got to think of all your combinations of 16 again. So we're going to get negative 2 and negative 8. Make sure it works both ways. Does negative 2 times negative 8 equal positive 16? Check. Negative 2 plus negative 8 equal negative 10? Check. All right. So now why do we do this diamond? Well, now in our generic rectangle, that gives us the two boxes that say number, pound 1x, pound 2x. That's the number 1 x value is my negative 2. So I'm going to go negative 2x there. And then my second number is negative 18, or negative 8, sorry. So that's going to be negative 8x. It tells us those two boxes because there's a plethora of combinations that can get you to negative 10x, right? We could be here all day thinking about different combinations. How are you going to break it up? So this diamond tells us how to break up the x in those two boxes. Okay? The other two boxes are always easy. It's the first upper left box will be your ax squared every time. So in this case, it's 1x squared. So that's what goes in the upper left box. Your lower right box will always be the c value, which is easy. That's just the constant. That's the number 16 in this example. Okay, so this should look familiar. We just spent a couple days multiplying polynomials, and we did a lot of multiplication with binomials, and we do the generic rectangle, and we get this, and we write it out as, okay, this is x squared minus 10x plus 16. We are going the other way now. We're taking the trinomial, and we're going to put it back into factored form, so it's going to be a binomial times a binomial. So here's the first part we're going to do with our generic rectangle. We're going to start in the upper left corner, looking straight across. So we're looking at x squared and negative 2x. Think to yourself, what's the greatest common factor of x squared and negative 2x? That's right, it's just x. So we're going to put x there. Then we're going to go to the upper left and go down at x squared negative 8x. What's the GCF of those? That's also just x. All right, so now we're off to the races. X times what gets you negative 2x? Oh, negative 2. And then x times what gets you negative 8x? Negative 8. So then we write out our answer, which is x minus 2 multiplied by x minus 8. There's our factors. Okay. A lot of students like the diamond and generic rectangle. It gives you a lot of structure and a process to figure out the numbers and how it works. So we will be using this method a lot. Let's look at another example. And again, I'm going to show you method 1 again just to show you the thought process for factoring. So we always look for GCF. This time I gave you one that has the greatest common factor. 3x squared plus 15x plus 18. The GCF is 3. So we rewrite it as 3 multiplied by x squared minus or plus 5x plus 6. Okay. So now we're going to look to factor the x squared plus 5x plus 6. All right. We know the 3, and we write it down in our parentheses. We have the 3 in front because that's the GCF. But now we're going to refactor just the x squared plus 5x plus 6. Okay, so what are our possible factors for that first term? 1x squared is going to be 1x and 1x. What are our possible factors for the c term? Again, the c is 6, not 18. It's the 6. So there's only a couple possibilities, right? It could be 1 times 6, or it could be 2 times 3. All right. So now we got to think to ourselves, what combination is going to give us x squared plus 5x plus 6? Is it going to be x plus 1 times x plus 6? Or is it x plus 2 times x plus 3? Well, if you did the x plus 1 times x plus 6, you'll end up getting 7x for your bx value. We want 5x. If you do x plus 2 times x plus 3, we're going to get that 5x. So that's going to be the combination that we use. So it's 3 times x plus 2 times x plus 3. Let's look at this same problem now, doing it the way you're going to be doing it today. Method 2 with the diamond and generic rectangle. So again, we pulled out the GCF, so we have 3 times x squared plus 5x plus 6. We are going to refactor just the x squared plus 5x plus 6 part, just that trinomial. So AC, A is 1, B is 5, C is 6. So AC is 1 times 6, which is just 6. So on my upper part of my diamond, I have the 6. My B value is 5. That goes below. All right, think to yourself, what two numbers multiply to 6 and add to 5? Oh, 3 and 2. All right, so now where does that go? In my generic rectangle, my upper right box is 3x. My lower left box is 2x. By the way, if you wanted to derive and you put 2x in the upper right box and you put 3x in the lower left box, you're going to get the same answer. It doesn't matter which box those go into. Okay, our upper left box, that's the ax squared. So that's just going to be the 1x squared. And then our lower right box is the c value. So our c value is 6. And we just have to be careful. It's easy to make a mistake. You look back at the wrong trinomial and you could accidentally write 18 there. Happens all the time. Okay, so you just got to be very careful. When you pull out a GCF, remember which trinomial you are factoring at that time. Let's start on the upper left side going horizontal. X squared and 3x. The GCF is just x. Start on the upper left going down, x squared and 2x, the GCF is just x. All right, going across the upper top, x times what is 3x? Oh, 3. Going down the first column there, x times what is 2x? Oh, just 2. So there's your factors, so we rewrite it as x plus 2 times x plus 3, but wait a minute, this is a mistake. If you give me the answer like this, I'm going to go, so close, but yet so far. Why? That's right, we forgot about the GCF we pulled out, the 3, right? So we have to have the 3 in front. So it's 3 times x plus 2 times x plus 3. You can always check your answers on an assessment, right? When you factor it, you should be able to multiply and get back to where you started from. If you just multiplied x plus 2 times x plus 3, you would not get 3x squared plus 15x plus 8 because you have to multiply that by 3 as well. Let's do 6 guided practice problems. I'm going to have you responding to my questions as we go through these problems together. So we're going to factor x squared plus 3x plus 2. The first thing I would like you to do is tell me what is AC and what is B for our diamond. So AC is 1 times 2 is 2, and our B value is positive 3. Now tell me, what two numbers multiply to 2 and add to 3? 1 times 2 is 2, 1 plus 2 is 3. Let's look at our generic rectangle now. The upper left box, what goes in there? Hope you got x squared. Now tell me what goes in the upper right box and what goes in the lower left box. So you should have 1x and 2x split up there. It doesn't really matter, again, which one went in the upper right, which one went in the lower left. It could go vice versa, and that's completely fine. But here's the key. Do you see how 3x is here? And 1x plus 2x, this part in there is equivalent to the 3x. That's how we broke up the 3x. All right, finally, what goes in the bottom right? That's right. You show the C value in the bottom right, which is just the 2. Okay, so now let's start here going this way. I would like you to pull out the GCF going straight across the top. What is that going to be? The GCF of x squared and 1x is just x to the first degree. Now, what's the GCF of the first column going down? The x squared and the 2x. What's the GCF? That's right, it's just 1x, right? 1x is all you can pull out of x squared and 2x. So now, let's figure out the factors. I'd like you to figure out what is our answer going to be now. So we went across the top, we went x times what gets us 1x, we got 1. As we went down that first column, we went x times what gets us 2x, we got 2. So our factors are the outside of the generic rectangle, so you should have wrote down x plus 1 multiplied by x plus 2. All right, we're going to factor x squared minus x minus 2. Tell me what is AC and what is B? AC should have went 1 times negative 2 is negative 2. And then B, did you put negative 1? If you put positive 1, you made a mistake. It's negative 1. Now tell me what are the two numbers that multiply to negative 2, add to negative 1? Should have got negative 2 and 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. All right, so let's do the generic rectangle. Let's set it up real quick. We're going to have negative 2x here. We're going to have 1x here. We're going to have x squared in the upper left box, negative 2 in the lower right box. If you need to take out a piece of paper to do this, go ahead and do that. But I want factored form now. Give me the factors. I'm going to start in the upper left. Going across, my GCF is x. Upper left going down, my GCF of x squared and 1x is x. All right, going across the top again, x times what is negative 2x? Negative 2. Going down the first column, x times what is 1x? Just positive 1. So you should have x minus 2 times x plus 1. The order of the factors does not matter, so you could have written x plus 1 times x minus 2. That is correct. What you can't have is you can't have x plus 2 and x minus 1. That would be wrong. That would give you the wrong bx value, right? That would give you a positive 1x instead of negative 1x. Okay? Now we have x squared minus 4x minus 45. What's AC and what is B? AC is negative 45. 1 times negative 45 is negative 45, and your B value is negative 4. Now tell me, what are the two numbers that multiply to give you negative 45? At the same time, they add to give you negative 4. So I hope you got negative 9 and positive 5, right? Negative 9 times 5 is negative 45, and negative 9 plus 5 is negative 4. So in our generic rectangle, we have x squared minus 9x plus 5x, and then minus 45 here in the bottom right. Set up for you. Go ahead and factor that for me. Tell me what the factors are. Let's start on the upper left, going across, x squared and negative 9x. The GCF is just 1x. Going down the first column, x squared and 5x. The GCF is just x. All right, going across the top, x times what is negative 9x? Is negative 9. Going down the first column, x multiplied by what is 5x? That's right, positive 5. So our factors are x minus 9 multiplied by x plus 5. So you notice on these first three, we didn't have a greatest common factor to pull out. There was none. It was always the greatest common factor to be 1, and that's not a GCF. It has to be something other than 1. So now we're going to do a couple where you have to pull out the greatest common factor first. So we have 2x squared plus 6x plus 4. You should be able to figure out the GCF. Pretty simple process. But I want you to write out the factored form now. So what's our new factored form after you pull out the GCF? I hope you got 2 times x squared plus 3x plus 2. We pulled out the GCF was 2. All right, so now we're going to factor the trinomial. Remember when I first taught you how to factor using GCF? I said sometimes we're going to then have to see if we can refactor this, but I told you not to worry about it then. Well, now we're worried about it. So now we're going to learn how do we factor this x squared plus 3x plus 2. Tell me what AC is. Tell me what the B value is. So AC is simply 2. 1 times 2 is 2. And your B value is 3. If you put 4 and 6, note your mistake right now. Have an aha moment. You looked at the original quadratic trinomial, the 2x squared plus 6x plus 4. But remember, we pulled out the GCF, so now we're factoring actually the 1x squared plus 3x plus 2. All right, this next step, you know how to do this. So two numbers to multiply by 2, add to 3. We already did one like this, was 2 and 1. So now over here we have x squared, 2x, 1x, and then we have the 2 here. All right, go ahead and factor that. So now, did you get 2 times x plus 1 times x plus 2? I bet a lot of you actually put x plus 1 times x plus 2 down, and you forgot the 2. Do not forget this 2, right? That was a GCF. It stays with it when we factor in this form. You have to have the 2 there, otherwise it is incorrect. All right, we're going to factor 3x to the 4th power minus 21x to the 3rd plus 10x squared. So the dead giveaway on this one is, you notice how we have x to the 4th power? What I'm teaching you right now is for factoring quadratic trinomials. Trinomials that are quadratic means the highest power is the 2nd. So when you see x to the 4th, alarm should go off in your head. That is, you need to pull out the greatest common factor. So can you do that for me? Pull out the common factor. What do we have? What times what trinomial? All right, so you should have x squared, because you can only pull out 1x squared, times 3x squared minus 21x plus 10. Oh, this is an advanced problem. This is actually supposed to be for tomorrow. I messed up, but that's okay. We get a sneak preview for tomorrow. So this time, you notice the a value is not 1. So think about this one carefully. What is AC going to be? And what's the B value? All right, AC is 30 this time, right? Because the A value was 3. So 3 times 10 is 30. And the B value is negative 21. All right, now come up with two numbers that multiply to get you 30. And at the same time, they add to give you negative 21. Uh-oh, bugaboo. What happens here? There aren't two numbers that multiply to give us 30 and add to negative 21. This turned out to be a great example I did by accident. So 1 and 30. So since they add a negative number, we know they both have to be negative, because negative times a negative is a positive. They have to add to a negative number. But 30 and 1 get you 31. 2 and 15 will get you 17. 3 and 10 will get you 13. And 5 and 6 will only get you 11. It's impossible. So this is an example of what we were doing before when I had you just pull out a GCF and then we were done. We actually are done right now with this, because this does not factor any further. So x squared times 3x squared minus 21x plus 10 on this one is the correct answer. So we're not actually going to factor this one when the a value is not 1. All right, last one. We have 5x to the 4th minus 10x to the 3rd minus 75x squared. I'd like you to pull out the greatest common factor. What do we have after you do that? Okay, I hope you found the GCF to be 5x squared. So it's 5x squared times x squared minus 2x minus 15. I think this one is going to factor for us. So now we're going to refactor this trinomial, x squared minus 2x minus 15. Tell me what AC is. Tell me what B is. AC is negative 15. B is negative 2. Now tell me, what are the two numbers that multiply to give you negative 15 and add to get you negative 2? All right, you should have come up with negative 5 and positive 3, right? Negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. Remember, with the diamond, it has to work both for multiplication and the addition. The rookie mistake students make is they find two numbers that multiply negative 15, and then they're done. and they don't double check to see does it also add to the number on the bottom. Has to work both ways. Now, I'm not going to give you the setup for the generic rectangle. I want you to do it yourself. See if you can factor this one all by yourself. Okay, hopefully you set up your generic rectangle. Again, your negative 5x and 3x could be flip-flopped. But I'm going to start here, pull out the GCF. I get x, and my GCF up here is also just 1x. X times negative 5 is how I get negative 5x. X multiplied by positive 3 is how I get the 3x. And then just double check the last box. Negative 5 times 3 is negative 15. Yes, it is. So our final answer is 5x squared. Did you remember that? Multiplied by x plus 3 times x minus 5. We always put the GCF in front, but by all means, you might have had 5x squared times x minus 5 times x plus 3, and that's acceptable. That is correct as well. All right. Let me know how you did with this problem and how you're doing with the lesson so far. Again, this is a multi-day lesson, and it's going to be multiple days of practice to get really good at factoring. So if you're feeling a little shaky, I'm just going to tell you that's normal. Even when we're in the classroom together, that's a normal process, much less doing it in the distance learning environment. But where are you at? So in closure, today we mostly had the A value was always 1 after we pulled out the GCF, except for that one problem that I made a mistake on. But that turned out to be a beautiful problem. But most times the A value, when we could refactor the trinomial, the A value was always 1. Tomorrow, we're going to continue this process, but now, sometimes even after we pull out the GCF, the A value is no longer going to be 1. It's going to be 2, it's going to be 3, it's going to be a half, it's going to be 5. Okay? The beautiful thing is the way I've taught you this today, tomorrow's process is exactly the same. Just be dealing with a little bit bigger numbers when we do the factoring, because you're going to be multiplying A times C. So you can imagine your numbers are going to get larger there. That's about it. So we will look forward to seeing you tomorrow. Have a great day, evening, night.